Right, welcome to the solution to exercise 11-5 located on page 541. Dawson Toys produces a toy called the Maze. The company's recently established a standard costing system with some standards, blah, blah, blah. During July, the company planned to make 4,100 toys, the normal volume, but actually produced 4,200 toys. Production data is as follows. Required, compute the following variances for July: direct materials price, quantity, direct labor rate and efficiency, and variable overhead cost variances. And then we got a couple other questions to answer. And for this one, we are, I believe, only doing parts 1 to 3. There we go. All right. So then, let's start. Oops. All right. A Q times a P, a Q times SP, SQ times SP. And this is actually 1A. So this is direct materials now. Okay. Production data. Okay, so 25,000 microns were produced for use in production at a cost of 60 cents per micron. Okay, so actual quantity purchased at an actual price of 60 cents. And the standard price is 75 cents per micron. So 25,000 times 0.6, 15,000 bucks. 25,000 times 0.75, 18,750. And so difference between them is a favorable $3,750 variance. Favorable. Okay. Now, we also find out, though, as we read the details of the problem, that it says 25,000 was purchased for use, blah, blah, blah. 5,000 of these microns were still in inventory at the end of the month. So we didn't actually use them. And remember, we do the price variance on the quantity purchased, but we're going to use do the quantity variance on using the quantity that we actually used, right? So we used how much? 20,000, right? So we bought 25,000, had 5,000 left over, so we used 20,000 as the actual quantity used times the standard price of 0.75. And then the standard quantity, standard price, we know standard price is going to be 0.75. Standard quantity, turns out we produced 4,200 toys, and the standard quantity per toy is 8 micron per toy, right? So 4,200 times 8 is going to be 4,200 times 8, which works out to 33,600 times 0.75 is 25,200, and then 20 times 0.75 is 15,000. So, wow, big variance, favorable. We're going down as we go as we move to the left here. So $10,200 favorable variance. Now this is interesting because often what happens is you might have a favorable price variance and an unfavorable quantity variance because you bought crappy stuff and it took more of the input to make the actual production. But that's not what we have going on here. Maybe we just managed to get a supply of really high quality stuff, and that allowed us to produce more products. Not sure, because I don't know what the heck a micron is when it comes to making toys. Anyway, there you go. Whoops, it's not 2, it's 1B. Okay, direct labor rate and efficiency variance. Oop, that was price variance. This is the quantity variance. So for labor, AQ times AP, AQ times SP, SQ times SP, and what do we know? 4,000 direct labor hours were worked at a total cost of $52,000. So the actual quantity was 4,000 times, don't know, but it resulted in $52,000. Okay, so actual quantity here, 4,000. What's the standard quantity for an hour? Looks to me like it's 12 bucks an hour. 4,000 times 12 is $48,000. And we know the standard price is, whoops, 12. That's not very good. 12. Number of hours actually worked, or sorry, standard hours to be worked. 0.9 hours per toy. So 0.9 hours times 4,200 is 3,780. So again, that's 0.9 times 4,200. Okay, so 3,780 times 12 is 45,360. Okay. So we've got some variances that are looking unfavorable at first glance here. So the labor rate variance, 4,000 unfavorable, and the efficiency, 45,360 to 48 is 2,640, and that is also unfavorable. Okay, so there's number 1 complete. Question says, prepare a brief explanation of the significance and possible causes of each variance. So there's a lot of different ways to answer this. I'm going to read you the stock answer here. A variance usually has many possible explanations. In particular, we should always keep in mind that the standards themselves might be incorrect. Some of the other possible explanations observed at Dawson Toy appear as follows. So, materials price variance, that's this 37.50 here, favorable. Since this variable is favorable, the actual price paid per unit of the material was less than the standard price. This could occur for a variety of reasons, including the purchase of a lower grade material at a discount, buying in an unusually large quantity to take advantage of quantity discounts, a change in the market price of the material, or a particularly sharp bargaining by the purchasing department. Materials quantity variance, 10,200 favorable. Since this variable is favorable, less materials were used to produce the actual output than were called for by the standard. This could also occur for a variety of reasons. Some of the possibilities include well-trained or supervised workers, properly adjusted machines, and materials with no defects. Labor rate variance, 4,000 unfavorable. Since this variance is unfavorable, the actual average wage rate was higher than the standard wage rate. Some of the possible explanations include an increase in wages that has not been reflected in the standards, unanticipated overtime, and a shift towards more highly paid workers. Labor efficiency variance, that guy there. This variance is highly favorable because the actual number of labor hours was less than the standard labor hours allowed for the actual output. Don't think so, unless we've done something wrong. All right, so I think there's something wrong with the solution here. But anyway, only in this explanation of the labor efficiency variance. So you can look at these individually and say, oh, it could be this, it could be that. I like to look at the interrelationships between them, right? So what does it suggest when we get materials for less than we expected and we use fewer of them, but at the same time, it takes more labor hours to produce the stuff and the labor costs us more? Is it possible that we have more skilled workers who are working with a lower grade of material, and therefore, because of their skill, they're able to take a bit more time, but they use less material, which saves money and has allowed us to use a lower quality material? Don't know. It's one possible scenario. Maybe there's a new technique out there. Takes a bit longer, but which would account for the unfavorable efficiency variance here, but it results in less input direct material. And you don't need as high quality direct material as you did when you came up with a standard. Don't know, right? So don't just zero in on the individual variances. Try to see if there's an explanation that justifies the pattern that you see among all of them. Okay, enough for 2. Let's get on with 3, which is the overhead variances. And for that, AQ times AP times SP and SQ times SP. And what do we know? Variable overhead cost is $12,340. And it's applied on per hour basis, so the same unit as labor, so 4,000 hours. And the standard variable overhead is 3.05. So doing the math, 4,000, 3.05, 12,200, 11,529. Small variance here, $140 unfavorable. The efficiency variance, larger, again, unfavorable, 671, whoops. And the spending and efficiency. All right, so this is variable overhead. That pretty much concludes the exercise.